A few days ago we talked about double replacement reactions and we discussed the word aqueous. Aqueous just means that it's dissolved into water. So if you take a compound like say NaCl, which is table salt, and you put it into water, it looks like the salt disappears into the water. But what happens really is that the Na is separating from the Cl and they become ions. So Na is positive, Cl is minus, and they float around as those little ions. And the reason it looks like it disappears is because those ions are so small you can't see them. So remember that aqueous means that it can break apart into ions. And don't forget that once it breaks apart, you have to put your charges. The charges is the key word for today. That's the biggest mistake people make. Strong acids can be separated into ions as well. We haven't learned about acids yet, so just write that down for now. We're going to come back to that when we get to our acid and base unit. Anything that's a solid, liquid, or gas cannot be separated. So they do not dissolve into water. They're not going to separate out into ions like aqueous things do. And anything that starts as an ion and ends as an ion is called a spectator ion, and I'll show you what those are in just a minute. You can actually take those out of the equation because spectator ions don't really change the reaction. And once you take those out, you're left with what we call the net ionic equation. So net just means what's left over after all the fluff has been taken out. For example, if you work a part-time job, your gross pay is how much you earn, then taxes come out, and the amount you walk away with is your net pay. So net is what's left over after you take out the fluff. So for any aqueous compounds, you're going to break it apart, write charges on everything, and then write how many you have as a coefficient. So what you'll need to do is go through your reaction and figure out what's aqueous and what's not. The reactants you can assume will be aqueous. It's the products that you'll have to check the solubility rules. And if it's AQ, again, you're going to break it up, put your charges on it, and tell me how many you have. And this is the example that I walked through in class. So anything that's AQ you can break up. For example, this can become sodium plus, and this can become SO4 2 minus. This can become Ba plus, and this can become Cl minus. So you're going to break apart all three of these, but the barium sulfate you're going to keep together because notice that it's a solid. And if you missed class and you're watching this to catch up, I will need to walk through this with you just to show you how to do it. If you're reviewing, keep in mind the spectator ions are the things that started as AQ and ended as AQ. So notice that sodium was part of an aqueous compound here. It's also part of an aqueous compound here. So sodium didn't really change from one side to the other, which means that it's a spectator ion. Same thing for chlorine. It started as AQ and ended as AQ. The barium and the sulfate both started as AQ, but notice that they ended as a solid, which means they changed, and that's important. So we're going to keep the solid. The spectator ions are the things that we don't have anymore. So one shortcut is whatever's not part of your solid is going to be a spectator ion. So Cl minus and sodium plus. The net ionic equation is what's left over after you take out all the sodium and chlorine. So you would have SO4 2 minus, don't forget your charge. You would have Ba 2 plus. Those are going to make BaSO4. So you literally just take out all the NAs and the Cls. But again, I need to show you how to do this if you haven't seen me do it in class. So if you're watching this to get makeup work, just come on by at lunch and I'll show you how to do it. And just a few more things for the reaction unit. The state of North Carolina wants you to know a few tests. You can use a burning splint, which is just like a piece of wood, to test for hydrogen, which we actually did earlier in the semester. If you remember the lab we did where we put the burning splint in the test tube and you could hear kind of a pop sound, that tells you if you have hydrogen or not. You can test for oxygen by blowing out the splint and then putting it in the test tube, and if it reignites, that means you have oxygen. And if you put the flame into the test tube and the flame goes out, that means the carbon dioxide is in there. And the last lab test that North Carolina wants you to know is that if you take clear colorless lime water and you add CO2, it becomes cloudy. So that tests if you have lime water. And that is all for the reactions unit. So you should have all the notes now to take the reactions test, but definitely come see me if you need help with any of those reactions.